we worked on math assignment 1009 in class. And so I want to make sure that you know how to do it. There's a couple of things that I really want to go over first, but first let me share with you what it looks like on here. So here it is, and what you're going to do is you're going to put your answers in these gray boxes, and I'll show you what those answers should be. Except for these last two right here, your answers are going to be, it's either going to be irrational, which is by itself, or it can be rational, or integer rational, or whole integer rational. So it can be any one of those things. You don't have to solve the problems, you just have to know what it means when you're looking at it. So let's stop that, and I'm going to share with my whiteboard and show you first what it means when we have something. I don't know if you've actually spent any time in your previous math classes looking at the things that look like this. That is called a radical symbol. And what you'll do is you'll see this symbol and it'll have a number in it. So radical 9. And what it's asking you to do when you see a radical 9 is find the square root. So whenever you have a symbol like this, your responsibility to solve is to find what the answer would be if you were to remove that symbol. So what you have to know is what that symbol actually means to that number. So we all know that when we are looking at a number and it has that, it means to square the number. It means to multiply it by itself. And the reason we call it squaring is because if you were to look at a square, if I were an engineer, I can make a square that was the same length on each side. So if this was 3 feet, each one of these other sides would also be 3 feet. And the reason we square it is because when you are wanting to find the area inside of the square, all of this, you multiply the length times the width. And since the length and the width are equal, it's 3 times 3, and it's squared. So that's why we just put the 2 there, because we know that it's 3 times itself. If you have a 3 here instead of a 2, right here, that's called cubing it because it's 3 times 3 times 3. And the reason we would call it cubing is because if this were a cube like this, we would be multiplying the length times the width times the height to get the area, or the cubic area inside, to find how much space there is inside. So to find a area of a square is the length times width, so that's 3 times 3, so that's 27 square feet. But you're finding the cubic area of a cube, then that's 3 times 3 times 3, which is 27 times 3. Alexa, what's 27 times 3?
27 times 3 is 81.
81. So the length times the width times the height means that this is going to be 81 cubic feet. Okay, so it's a brief explanation of what it means to square something. What you're wanting to find out here is the opposite. So what number times itself is going to equal this? Well, we know that 3 times 3 is 9. So the square root of 9 is 3. Okay? If you wanted to find out the cube root, you would see the radical with a little 3 right here. You see 81. Cube root of 3 is also 3. And if you look at number what is it, 6 on that assignment, when you open it up, it's going to say this with a negative sign here. That is equal to -3. So when you look at a number, it's not just the number itself, it's all the things that equal that number. And it can be written in any number of ways. You can write 2 as, let me see, let's clear the whole board. You can write 2 is equal to 4 divided by 2. You can write it as 1 times 2. You can write it as 2 over 1. So basically, they're just whatever it is that equals 2 is going to be 2 as well. So, I mean, it's all equal, no matter if it's the number itself or a different way of mathematically writing that number. So that said, we're going to look at how we place radical numbers on a number line. So if you have a number line here, this is going to be our 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, in assisting you with this, you're going to use your graph that's like this. Everything right here is a number that has been squared. That means that if you look at here a yellow number, there's the 81 that we were talking about just a minute ago. 9 times 9, which is 81. 9 squared is 81. 81, the square root of 81 is 9. So we're going to look at what each of these numbers looks like as part of a square root. 4, 6, 7, 8, 9, and 10. Well, we know that the square root of 1 is the same as 1 times 1, because when you square 1, you get 1. So the square root of 1 is 1. When you square 2, you get 4. So radical 4 is equal to 2. Talking to my daughter. Radical 9 is the same as 3 times 3. So radical 9 is 3. Radical 16 is 4, because the square root of 16 is 4. The square root of 25 is 5. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is what, Eleanor? 81. My kid knows how to do math. And 10 squared is 100. I am funny. Don't forget it. I just want to make sure that you understand that the radical 1, or finding, the square root of 1 is the same as 1. The square root of 49 is 7. They are both the same. They are equal. So radical 49, or the square root of 49, equals 7. All along, up and down the path there. So when you are given a question like, is a number 7, I'm not asking you to solve it, but just in the case that we are going to be having to place radical numbers on the number line, if you have radical 2, now that's a really, really, really hard number to solve. So we're not going to get an exact number. It's going to be one of those, it's an irrational number, because the decimal point goes on forever. And so we're not going to get ever an exact number that will multiply itself and become 2. So we have to do an estimation. And the way we do that is we know that radical 1 is 1, and radical 4 is 4. So radical 4 is 2. And so we will know that 1 point something something is going to be radical 2. So we're going to place that right here. Now, if you're given radical, well, I mean, it would be easy to note to see on here how they're placed, but let's see here. Radical 17, you know it's going to be between 16 and 25. But more importantly, it's going to be 4 point something something. So it's going to be closer to here than it is to the other. If you're given the actual number of, well, I don't know how to explain this exactly. Well, we'll go more into it about how to place them onto the thing. What you actually have to do is know that when you're trying to find the square root of something, and it's not one of these that's an exact square root, it's going to be somewhere in between there, and we have to place them as best as we can. So, like, we're going to break this area down between 4 and 5 into 4.1, 4.2, 4.3, 4.4, and then determine where on that number line that's supposed to be. And you're going to be doing a lot of trial and error multiplication. So, like right now, I can tell you, just based on, you know, using a calculator, which you're not going to be able to do at some point, but for right now, using this, hit the square root of 17 square root, there we go. It's 4.123. So it's going to be between 4.1 and 4.2, actually right there. And that's about as close as we're going to be able to get as to an estimation of where to put it on the thing. So if you're going to be looking at radical 18, so 18 square root, it's 4.24. So it's going to find itself actually right here. So, and that's not an exact spot on the number line because it's not an exact number that we have. Okay, I didn't want to get too much into this right now because it's something that we're going to be going over a lot more in depth later. Just suffice it to say that almost all square roots are going to come down to being irrational unless they are one of these yellow numbers right here. Okay, if it's a yellow number, it's going to be an even square, and other than that, it's going to be a big jumble of numbers. So if it's not on here, you might pretty much almost always consider it to be an irrational number. That's all I wanted to say about that. Okay, so now we're going to clear that up. And just to refresh, you have this in your folder, in your blue folder, your blue book, or, wait, hold on, or green book as the case might be, this right here. I'm going to recreate right now, very quickly. Unusual size, and that's where you're going to find stuff like pi, radical 2, 6/7, 2/7. I don't know if 6/7 is actually an apt thing, but all of these numbers here represent numbers that fit the criteria of irrational numbers. Okay, so this is the irrational outland over here. Where is it? There we go. Irrational outland on this side. So this is the graph, and this is a fun graph, but it's a graph. You know, and it's, again, right here, it makes a little bit more sense here. It's a lot less, you know, quickly drawn. That you use to inform your thinking on the math, forming ourselves on how to fill out that form that's on the Google Slides that is on assignment 1009. Never have I had a crazier video experience. Okay, so the first one is for -3. All right, so -3, you know that if it's, let's see, let's pick a fun color here, pink. If it's -3, there is no decimal or portion of a number here, and it's not 3 and a mixed number. So it's just 3. So that means you know right then that it's rational. Okay, because remember, in order for numbers to be considered irrational, they have to have a decimal that goes on forever, or, well, basically a decimal that goes on forever and does not repeat. Okay. So there is no decimal, so it's going to be a rational number. Also, one of the indicators, or one of the things that we have to look at now is, can it go into this area right here? Oops. Can it go into the lords and ladies area? Now, the kingdom of rational numbers is going to have whole numbers, which are these numbers, and they're going to have positive and negative numbers, which are these numbers, and also the fractions or portions of a number. So it's important to understand that anything that is in the kingdom, which is just whole numbers, can be everywhere in the whole kingdom. Okay, so if it's a number here, it's going to have 3 different titles. By here, I mean right here. It's going to have 3 different titles. It's going to have whole, integers, and irrational. But if it has a negative sign and it doesn't have the decimal, it's going to be an integer. In which case, it'll have 2 titles, integer and rational. But if it is a portion of a number, whether it's positive or negative, if it has a portion of it, it can only be in this area right here, the rational numbers area. So its only title is going to be rational. And of course, anything that's on this side is just going to be irrational, and that's it. Okay, so -3 can be in the rational part, and it can also be in the lords and ladies part. So it has 2 titles, and those 2 titles are rational, integer, or integer, comma, rational. So in the slot, in the little box next to -3 on number 1, you're going to write rational, comma, integer, or integer, rational. Either way, it doesn't matter. But as long as you have both of those titles to that number. The second number is, let me erase all this. The second number is 4.5 with a line over it. That line means that it's going to be 4.55555 all the way to infinity. So it is a number that goes on forever. However, it is not irrational because that number repeats. 55555, etc., etc. So it is still rational. But if you look, it is a 0.5, meaning that it is a portion of a number, so it cannot go in the lords and ladies. And if it can't go in lords and ladies, it certainly can't go into the castle. So this is only a rational number. Rational is the only title it has. So for number 2, the answer is rational. The next one, if you look at it, I'm not going to do it all because it's a big, huge, long series of numbers. And those numbers do not repeat. And if you look, there's a ... at the end of it, meaning that it goes on forever. That series of numbers just keeps on going and doesn't repeat at all. Therefore, it is rational or irrational. It's in the irrational numbers. It is a number of unusual size and it lives in the irrational outland. So I have gone over 1, 2, and 3 for you. Number 1 is both integers and rational. Number 2 is only rational. Number 3 is irrational. One of these, you're going to have to solve the fraction out. It's 6, which is -9/3. Remember that all fractions are just division problems waiting to happen. So if you have 9/3, it is an improper fraction, and you will need to find its proper number, which you would do by division. So 9 divided by 3, but it's negative. So the answer would be -3, which we've already covered in number 1. So you already know that answer. If you have any questions or problems, please call me, please text me, please email me, please send a courier pigeon, whatever. However it is you need to get in touch with me, and I will help you, I promise. But by Friday, I need you to have that filled out and submitted to Google Classroom. If you have any questions, again, please let me know. I'm here to help you. All right, I'm going to do some heavy editing on this, and hopefully it'll turn out okay. Thank you. Bye.